You've done the first part of experiment 4, and it will be 2 weeks before you weigh your product and complete your report. But the biggest part of the report is to convert your net ionic equations into molecular equations, and you could really get a head start if you worked on that now. I think this is the most important part of the experiment, getting practice writing the equations. So what I've got here is the first reaction that you had in your pre-lab for dissolving the copper in the nitric acid. In your pre-lab, you wrote the net ionic equation, and I can tell that's a net ionic equation because I see charges in the equation. I see ions. Now, you got that equation by noticing it was a redox reaction and using half reactions to balance it. That's the big part of the job. Now all we have to do is convert the net ionic equation to a molecular equation. And here's where the pictures of the beakers come in so handy. What makes a molecular equation is that we pair up the positive and negative ions together. That disguises the charge in the equation, but it doesn't disguise the fact that there really are ions present. So I'm going to get started on that. I am going to pair up the H plus with the nitrate. That's going to leave me 2 H pluses I can't do yet, but that will give me 2 HNO3s when I pair 2 H pluses with 2 nitrates. That's just a little tidying before I really get going. Now, I see a net positive charge there. I'm going to have to disguise that positive charge with a negative ion. And now I am so glad I've got the picture of the beaker. That's exactly the same picture I showed you in the pre-lab video. The only negative ion swimming around in that beaker is nitrate. So I'm going to add some nitrates to the left-hand side of the equation. I'm going to add 2 nitrates there to make 2 nitric acids. And I'm going to add 2 nitrates there because once my equation is balanced, I've got to keep it balanced. Now, how does that work in terms of chemistry? I saw that I was allowed to add nitrate on the reactant side because there was nitrate in my beaker. Was I allowed to add it on the product side? Yes, indeed. I still had some in my beaker. So what I have in my beaker, I'm allowed to use. Now, this might look a little funny to you that I'm telling a lie, but if I finish off this equation and put the states back on, I didn't put the states on before because I didn't want to get writer's cramp. The state for the copper nitrate was aqueous. And what does that mean? That means copper ions swimming around and nitrate ions swimming around. I am telling you the truth. So one last pitch for the beauty of drawing the equations. Not only does it show you the products of the reactions, it shows you what's left over as a spectator ion, and it makes it so much easier to complete your molecular equation. Hope that gets you started. Have fun.